Okay. So actually what we were doing previously, what we were doing,
So transmission of heat
basically a
and
heat
conductivity.
was given by Q. So rate of flow of heat depend on rate of flow of heat. You can consider this as current. This is actually the current of heat. Yeah, just like in here, Q
Yes,
by
sir.
T was what? A current. In a similar fashion, a Q
I.
a T depend on many things. Just like a I depend on area, something, something, something. And you had what? K, A, difference of temperature, T2 minus T1 divided by what? Length. This is exactly same as this corresponding to current, if you all remember. Was given by what?
Yes, sir.
If you remember. So basically your Q by T was basically a current. Now, when we consider a cube and which has a difference of temperature of what? 1 degree, and which is 1 centimeter, which has a length of 1 centimeter, breadth of and height also of 1 centimeter. Basically, it is 1 centimeter cube. Basically, the amount of heat transfer from here to here in 1 second, where the temperature difference is 1 degree Celsius across 1 centimeter is basically called your, and 1 centimeter square area is basically called your thermal coefficient of thermal conductivity. Yeah.
Yes, sir.
So the definition is basically the coefficient of thermal conductivity is defined as the amount of heat flowing in 1 second across the opposite faces of a cube of side 1 centimeter maintained at a temperature of 1 degree Celsius. Clear? Is it clear?
Yes, sir.
Now what we are going to do is thermal gradient. Gradient. Do you know what does gradient mean? Anyone has an idea what does thermal or gradient means? Hmm? If you look at the relation of Q,
Change.
it will be
Change.
what?
Cost of the change in just.
Okay, T2 minus
How
T1.
does it change in respect to SF?
Actually, with respect to time, rate of change with respect to time is what? Your current, and rate of change with respect to your temperature is basically a thermal gradient. This is basically whatever the term which is sitting over here. Yeah. This is basically the term which is sitting over here. This is basically called here thermal conductivity divided by, should I use X or L? If you consider any length, arbitrary length, it's just given by what? Let's consider a scenario. You have a what? Unit length of what? Let's consider this as point x1, this as point x2. Clear? Everyone, is it clear? You consider this is a metal thin wire. The position of one is at x1 and one is at x2. This is your origin, or this. One of your point is at origin and another point is at where? Point is at what? X2. Clear? So your length will be given by, what will be the length? X2 minus x1. Is this point clear or not? Let the temperature over here will be T1 and temperature over here be T2. So the difference in temperature is given by, what? T1 minus T2, or T2 minus T1, sorry. It's given by what? T2 minus T1. Is this point clear or not? So if you divide this two, what you will get? T2 minus T1 divided by X2 minus X1. Now, if you know the definition of what derivative, what you will get, this can be basically written as what? This can be written as what? dt by dx. Is it okay?
Yes, sir.
I think it's okay. Now that one was basically a what? Gradient. Now this is basically a what? Thermal gradient. Clear? Now higher this, the faster the gradient will be, the faster the heat will flow across the length. Basically, what does this signify? Anyone? What does this physically mean? This is basically rate of change of temperature.
Rate of change.
Okay, yes, rate of change of temperature with respect to distance. With respect to distance. Clear? Now let's consider this. What are the factors this will depend? Let's you have a metal rod. Let's consider this as a metal rod. And let's put some partition over here. And this is at, let's say, this side of the bar is at T1 and this side of the bar is at T2. Now, whatever the particle which is sitting over here, will the temperature difference will be faster? Matlab, the rate of change of temperature with respect to distance will be faster over here or from here to here. Is this point clear or not?
No, sir.
Okay. Let's consider the 2 points. Okay, let's say this is at 100 degrees Celsius and this is at 10 degrees Celsius. Okay, and let's consider this two. Let's consider this end of the bar. What do you, let's give it a number or position x1 or x2 or 1 centimeter. And this is at what? This is at extreme heat of what? 1 degree. This, let's say this rod is at this point, this rod is at what temperature? At this part of the rod is at 100 degrees Celsius and this part of the rod is at 10 degrees Celsius. Clear? Now x2 is how many? Let's say 2 centimeters. So the distance between the rod is what? 1 centimeter. Is that point clear? Rita, Deepika, Avinash, anyone? Is this point clear?
Yes, sir.
When you heat the rod, this part of the rod was at 100 degrees Celsius, which was at the position this. So the distance between these two is given by what? 2 minus 1, which will be what? 1 centimeter. Clear? So the difference in temperature will be how much? T1 minus T2 or T2 minus T1 will be how much? T2 minus 90. So the gradient will be how much? 90 divided by 1, which is basically 90. Clear? Now let's
Yes, sir.
consider this scenario. Let's consider this is at this side and also it is at 10 degrees Celsius. This is at, let's say, 3 centimeter. So the difference is what? Again, the same thing, but it will be dt by dx will be how much? 90 divided by 2. Clear? Now what does this means is
Yes, sir.
this will get heated faster. Clear? Because the gradient is more over here. And this will heat up slower. That we all know. Do we know? Because this is
Yes,
how
sir.
the heat disperses. Because if you start heating this pan, or if you have a rod, immersion rod or anything, it's compared to liquid, but I think the concept is okay. If you start heating this with an immersion rod, clear? This part of the what will get hotter faster and the farthest one will be coldest because the heat will start flowing in this manner. So this Firstly, this will be heated, and after the heat will radiate outward. Is this point clear or not?
Yes, sir.
If you have a pan, clear. If you heat it at the bottom, first this part will start heating up,
Yes, sir.
Yes,
and
sir.
this will, and here this side will be coldest
Yes,
because
sir.
the heat will radiate slowly. After some time, it will be all the will be uniformly heated. Now, if you check the
Yes,
distance
sir.
between over here to here will be it's what more. So means your gradient is also more, is less. Gradient is less, which means how fast it will flow with respect to distance. Clear? That is what your temperature gradient gives, because that is
Yes,
how
sir.
your temperature dissipates. If you plot this, it will fall off like this. Clear? Now over here also the gradient is low because it is at closer temperature. Because it is almost at the same temperature. Now if you check, the temperature gradient is higher around this region. Clear? This is what does that mean. This is how your heat radiate outwards. Clear? Is this point clear or not?
Yes, sir.
Now after this, what we have to get? Now one more thing. Now basically the quantity that gradient is rate of fall of temperature with respect to distance. It is what? Rate of fall of temperature with respect to distance. First, the gradient will start getting slower and slower. What does that mean? It will become like this. The gradient is negative, okay? Why the gradient is negative? Because the temperature is getting dissipated, because the heat is flowing from this zone and it's decreasing, and after certain time it will be at equilibrium. Clear? This is what you have. Is this point clear? As the temperature decreases with increase in distance, as the temperature decreases, the temperature was highest over here. As the temperature decreases with increase in distance, the further, the lower the temperature it will be. The quantity dq by dx starts what? It's negative, and the quantity, this is what? Negative. Clear? And it's called temperature gradient, basically. Now, q by t was your current or rate of flow of heat with respect to time. dq by dx was is called temperature gradient. This is how it changes with time. This is how it changes with length. These are the two difference. How heat changes with time. Time. How heat changes with distance. I think this point is clear. Now next we are going to do what? Dimension of K. So what will be the dimension of K of thermal conductivity? Now again what you can write is Q by T can be written in this form. K by A del T by del X, temperature gradient, into. Clear? Is this point clear?
Yes, sir.
This is how we have defined rate of flow of. Now this has in time, and this is also in position. This is how it will change. Now this will govern how your heat flows in your position with respect to different distance, and how the temperature changes with respect to time. Clear? Now K can be, now this has a dimension of what? A dimension of what? Let's do the dimensional analysis. Q has a dimension of what? Q is basically energy. Now energy has a dimension of what? Energy can be written as
Joule.
what? Okay, joules. Joules is basically force into displacement. Dimension of force was what?
Yes.
Mass into acceleration, no?
Acceleration. Yes, sir.
Mass into length into time inverse square into again length. So m L squared T minus 2. This is a dimension of your heat. Clear? Is this point clear? So the dimension of time is basically Q was m L squared T minus 2. So dimension of time is what? Second. Sorry, T. I think it's written in T, no sir? T, I think. T minus 1. After that, the area, dimension of area is what? Length square. So a dimension of dt by dx will be, now this is slightly complicated. Now how do you find this? dt is basically what? dt is basically what? Has a dimension of actually degree Celsius or something. So for a timing, we'll just write it degree or phi. Degree Celsius or Kelvin. So just write this, let's write this as theta or temperature. Clear? And the length is length inverse. Now if you put this over here, what you'll get? K, dimension of K as what? M L T Q theta. Now this theta may be Kelvin or degree Celsius. Clear? Kelvin or degree Celsius, could be anything. Is this point clear? So the dimension of K is given by this. The unit of the unit of your thermal conductivity was what? Previously, I think we have done. What was the dimension? What was the unit of conductivity? Conductivity was basically what? Calorie per centimeter. Then what was there? Calorie per centimeter.
Celsius,
Second.
degree Celsius.
Okay, degree Celsius. So this was a unit of thermal conductivity, and this was a dimension of your thermal conductivity. And next we are going to do what? Thermal diffusivity. Clear? Thermal diffusivity. This is basically defined as a ratio of what? Thermal conductivity by thermal capacity. So what was thermal capacity? By thermal capacity per unit volume. Which is defined by a thermal diffusivity is given by H. Clear? Now, if a specific heat is given, what we used to write out specific heat by C. C used to give you a specific heat. And to get a thermal capacity, what you used to do? Thermal capacity was given by mass times a specific heat. Specific heat capacity. So basically, a thermal diffusivity H is given by what? K by mc per unit volume, which is basically a K V by m into C. Clear? Is it clear? Or also H can be written as K, rho is the density divided by C is your thermal capacity. Rho, what we have written, mass per unit volume. So this is your thermal diffusivity.